So hello everyone, welcome to the final session for today. We will be discussing about application of risk analysis and we will be discussing about risks for ship maneuvering in restricted areas. Well, I know that you are all in the mood for reading during this weekend for your exams next week. So we discussed with the rest of the trainers and we said that we would reduce your workload today, so we'll be finishing a little bit earlier. However, a short exercise, a short homework will be given to you towards the end of this session. It's nothing much. You'll see it's gonna be very easy. Again, pass fail grade for this one too, along with the previous one. By the way, for those of you that weren't 100% synchronized during the morning session, we did the case study on risk planning, and I'm waiting. We have extended the deadline for Monday, 9 p.m. UK time, that is 11 p.m. GR time, and 10 p.m. Central European time. So, in addition to that, to this deadline, we will also be expecting from you guys a short, very short write-up later today. Some questions only that you need to answer. And again, let's go on to today's lecture. Now, first and foremost, the IMO standards on maneuverability have evolved over a long period of time. Well, actually, maneuverability is trying to turn the ship around in an area or wherever, and there is an elevated risk when this has to take place in restricted areas and limited areas, within ports, within riverbeds, stuff like that. So the IMO standards have really evolved over a long period of time, and these are actually applicable to vessels that have a length of over 100 meters, and to all gas and chemical carriers, including that is LNGs. And this is why we have to stick ourselves and comply with these regulations. Actually, for the gas chemical carriers, there's no minimum length requirement. Even if you have a ship, let's say, of 1 meter long, the regulations apply to that ship. And last but not least is standards of maneuverability do not apply to high-speed crafts. Now, all types of rudders and all types of propulsion devices are covered by these standards, I have to say, and these standards are actually based on the assumption that the maneuverability of a vessel can be judged by comparing some characteristics of trajectories of standard maneuvers. Some of them are the following. First, the turning ability as measured by the tactical diameter and advance of the turning circle maneuver. Course changing and yaw taking ability measured by the first and the second overshoot angles of the zigzag maneuvers. The initial turning ability measured by distance traveled before a vessel changes course 10 degrees during a zigzag maneuver. And the stopping ability measured by the track reach from a crash stop test. In addition, straight line stability course keeping ability is also included in the standards, as is the measure of the width of the stability loop obtained from a spiral maneuver. Now, these are some example IMO standards. And the first one is the turning ability, the measure of maneuverability. The criteria, the standard is the tactical diameter and the advance. The maneuver style is a turning circle. And the IMO requirements and the rating system and the guide requirements and status from the American Bureau of Shipping are on the next three columns. Now you can see that there are a lot of criteria there, a lot of standards out there, and actually the intention is to be as safe as possible and to lead the ship safely through a passage to its destination and transport the cargo, of course, in a correct manner. Now, some design elements that are important to maneuverability: the rudder size and its effectiveness, the ability to transit at slow forward speed, the propulsion and the proper propeller characteristics, the number of available engine reversals, the adequate horsepower for control, extra reserve angle, rudder angle needed to allow for ship crabbing from wind forces or for moored ship sanction, the visibility from the bridge and the bridge arrangement in general, the hull form squad, the trim that is in the sinkage characteristics, and the effect of bank forces on moorings and passing ships, the air draft, of course, especially for ships that have a high superstructure. That's a very, very crucial theme. The emergency anchoring ability: how fast can you anchor actually? Can you drop the anchors? And the amount of tow line leads and line access. Now, with regards to limited waters, what does IMO consider as limited waters? IMO considers an area of depth of up to 40 meters and distances to the nearest navigational obstruction, the nearest navigational obstacle, less than 3 meters. So this actually includes straits, outlets of rivers, riverbeds and river mouths, channels, the port area, the port water area, and other water areas with comparatively small surface and depth. These are actually characterized by limited possibilities of maneuvering. So especially for the large ships, the ultra carriers and the larger of them, actually they cannot maneuver on themselves and they need external assistance like a tugboat. The necessity of maneuvering in accordance with planned tracks at definite trajectories with participation of pilot or individually if and only if the shipmaster knows exactly the waters in this area. The necessity of adaptation of movement to local rules, and this is why in most of these cases either the port master or the Coast Guard have developed and have released specific rules on how to move or where to move or when to move, so as to keep everything safe. And the occurrence of navigational natural obstructions like shallows, reefs, or other similar things, as well as artificial obstructions like wrecks or minefields. For example, one of the most important artificial obstacle in Europe these days, it's in the river Danube, where there are a lot of wrecks, even some of them from before the Second World War. So you have to be extra careful on where you are heading with your barge, unless you want to find yourself in a very peculiar situation. Now, the characteristics of limited waters. First of all, they have the geometrical dimensions of the area, of the water area, the width, the depth, and its shape, and connected the occurrences. The port structures, the locks, the wharfs, the navigational markings, either fixed or floating. The hydrometeorological conditions like currents, tides, the unprofitable directions of wind, ice, etc., etc. Traffic vessels that restrict accessible area for navigation or for maneuvering. So if there is a huge traffic of vessels in the area, these restrict the available area and produce a limited space for you to maneuver. The large number, of course, of other ships like barges, bunkers, fishing boats said that smaller structures that are out there, that operate out there, and make difficult for seagoing ships, especially for the larger of them, to maneuver. Navigational obstacles like ships on anchor, moored ships, docks, dredgers, hydrographical ships that produce a busy environment too. The activity at ports areas and areas like modernization, reconstruction, or new construction that restricts the movement of ships, like building a new terminal, so on and so forth. The AIS system and the required accuracy, all the VTMIS, LRIT, the AIS, and all the similar systems have an accuracy of their own. So, in order to be on the safe side, this sort of space that you need to move in is quite large in these cases, which reduces the available capacity of the seaway, and other rules, international or local rules, that are put on ships on a specific trajectory for movement. Now, the safety of navigation said that the objective is to be safe so that navigational accidents will not occur, or if these navigational accidents occur, the consequences would be manageable, including the no loss of human life, no health damages, no damages or losses of cargo and of the ship, no environmental pollution, no damage to port structure, financial losses, etc., etc. So that's the main objective, to have a safe navigation. Now, probability of an accident. The navigational accident-free performance of a maneuver in specific conditions cause an accident to occur. The error-free performance of the navigator. So if a navigator is knowledgeable and knows what he's doing, so it reduces the probability of an accident, and vice versa. And last but not least, for certain, it's the technical reliability of the ship itself. So if you, sort of speaking, in other quotes, order your ship to turn, will she turn or not? So it's a mixture of those three main attributes. And in order to be safe, to have a safe navigation, you have to pay close attention to all of them. Now, ship safety assessments. Some criteria in order to assess with regard to the safety of the ship. The limited area, the limited waters are characterized by a great number of risks, of course. However, the following conditions should be carefully and always monitored when you are on board a ship and you try to navigate safe. The first is that you are trying to maintain the under-keel clearance. The second is that you try to maintain the proper distance to navigational obstacles. You also try to maintain the proper air draft. You try to avoid collision with other floating structures, and you try to maintain the proper berthing kinetic energy so that you can not be dragged into or onto another structure. But at the same time, of course, and these are the mega trends at this time, you have to be as quick as possible, fast turnaround for ships. You have to get in there quick, and you have to unload your cargo quicker, and you have to get out of there even quicker. So it produces a very, very difficult environment. And you also, at the same time, have to comply with all the precautions and all the requirements and all the legalities, which means that you don't really have time to check pretty much everything. However, again, in order to to navigate safely, you have to pay extra attention and extra monitoring on the issues of safe navigation. Now, some risks. External hazards. These include hydrometeorological conditions, winds, currents, waves, tides, stuff like that. Improper ship-to-berth interaction during berthing. Improper ship performance during the navigation along the approach channel with respect to drifts, with respect to the course itself, and with respect to the position along the approach channel. Traffic, non-standard initial position or non-standard speed, things that will confuse you or the port master or the masters of the other ships or of the other structures. All of this may create a risky environment. And of course, there are also internal hazards within the ship. The human factor, of course, in all of the cases is the most important, and it's always indicated as the most important risk factor. And actually, Professor Zanatos made a good introduction yesterday about the human factor. He will also conclude on Monday with some more notions for the human factor. And also, last but not least, technical failures. When the ship itself, she fails you in your orders, as we've said before. So these are all risks that produce a very, very unstable environment and really can break or can produce accidents. Now, this is pretty much it for today. I told you that we will be very, very brief. It's on its own. It's a huge, it's a vast concept. It's a vast topic. This one. I think that we made a very good introduction on the maneuverability issues and the maneuverability risks. And what I want you to do is, I want you to select one of these two videos. The links are over here. It's the pushing thing, the first video, and the hardest maneuver I've ever seen is the second one. The first one is a container ship, and the second is a Roro ship. Select one of these two, sorry, whichever you want, and using the bow tie approach that we introduced briefly earlier, I want you to list the 5 most important events based on the bow tie approach. And based on what we've said now in this section, I want you to list the 5 most important events and list backwards what are the threats that will be producing these events and what are their consequences of these events and how you can recover those events. Now, your task is just to do that. It's gonna be no more than 2 pages long. If you can draft it on a bow tie diagram on a single page, even better. I will be expecting this homework on Monday, 11 o'clock UK time. If you need any question or you have any issue whatsoever, I'm going to be around, so feel free to ask me. I'm going to be around here for the next hour or so. Please feel free to ask me in here or to send me an email in my email address. And if you have any questions during the weekend, feel free to send an email to my email. I'll be taking them regularly during the weekend. So, said that, have fun case studying and have fun doing your homework. Also have fun reading all the material for the exams next Wednesday. And we'll be in touch. If you need anything, just send me an email.